Hey class, how you doing? I realize I didn't really go through a full example today in class, so I want to make sure that I got through a full example. So I want to help you out. The problem I'm going to do right now is number 10 from page 270. All right, so in this problem, they give us the function f of x equals 1 over x, and they ask us to find the area under this curve using RAM, which is rectangular approximation method. They don't say LRAM or RRAM or MRAM, so you can do whatever you want. I'm going to do all three for you so you can see the difference, but you really only need to do one for the problem. Okay, so I broke out GeoGebra, and we got it going on here, and then I put it in a PowerPoint so that I could draw on it. So let me get that set up. Okay, so this is what's going on here. So what we want to do is we want to take our function. Let me turn on the pen. All right, so our function is f of x equals 1 over x. And we want to find the area under the curve from x equals 1 to x equals 3. So we're looking for this area down here. Okay, now this is a pretty complicated area to approximate, or to actually figure out, but to approximate is not so bad. All right, so what we're going to do is, they don't tell us how many rectangles to make, so we get to choose. So I'm going to choose to make each rectangle have a width of 1/2. So that'll give us one rectangle, two rectangles, three rectangles, and then our fourth rectangle. All right, so the first one I'm going to do is a left rectangle approximation method. Okay, so to approximate that, I'm going to look at each rectangle, pick its left height, draw straight over, and then complete that rectangle. Same story here. Same story with the third rectangle, and same story with the fourth rectangle. All right, so then what we're going to do is we're going to calculate the area of each of these rectangles, add them up, and that'll be our approximation. Now, obviously, it's going to be an over approximation because we are including this part, this part, this part, and this part right here, which is going to be in our approximation, but not really under the curve. So we're going to have a little bit of an over approximation, but at least we have an approximation. Okay, so each of these rectangles is going to have a base of 0.5. Okay, to get that in a more difficult case, what you want to do is figure out the total length of this line, which is 2, because 3 minus 1 is 2, and then we divide by how many rectangles we want to have. All right, in this case, we have 4 rectangles. So 3 minus 1 is 2, 2 over 4 is 1/2. Okay, so that's how you can figure out the width of each rectangle in a case where it's not so easy. All right, so that's going to be the width of each rectangle. So to figure out the LRAM, what we need to do is figure out the height of each rectangle. So what we want to do is evaluate this function, figure out what these points are. So the height here is going to be our function f evaluated at 1. 1 over 1 is going to be 1. Then we evaluate it at 1.5. So f of, sorry about that. F of 1.5 is going to be 1 over 1.5, so 1 over 3 over 2, which is going to be 2/3. All right, then we want to evaluate f of 2, which is going to be 1 over 2. Then we want to evaluate f of 2.5, which is going to be 1 over 2.5. It's going to be 1 over 5 over 2, which is going to be 2/5. Okay, so now we have the height of each of these rectangles. So what we want to do to find the LRAM is multiply 0.5, the base of the first triangle, times the height of the first triangle. Then add that to the base of the second rectangle, plus the height of the second rectangle, plus the base of the third, times the height of the third, plus the base of the fourth, times the height of the fourth. All right, so that's going to be our left rectangle approximation method. I'm going to crank that out on the calculator really quickly. Sorry, so we got 0.5 times 1 plus 0.5 times 2/3. Eek. A little trouble here with the parentheses. Sorry, I know you can't see this. Plus 0.5 times 1/2 plus 0.5 times 2/5. And according to my calculator, I get 1.283 3, 3, 3, 3. All right, so that is our left rectangle approximation method. All right, now what I'm going to do is I'm going to go for the right rectangle approximation method. So let me do some cleaning up here. I can leave a lot of that. A lot of that will still be helpful, but I'm going to switch colors. So I'm going to go with blue. All right, so now we want to do the right rectangles. Okay, so we still have this same idea here, except we're going to use the right sides to create our rectangles. Right side, right side. So they still have the same width, but now they're going to have different heights. All right, so now this point right here doesn't help us out so much. This one still does. This one still does. This one still does, but we got to figure out this one. This one is f of 3, so that's going to be 1/3. Okay, so now if we want to do the right rectangle approximation method, everything's still the same. 0.5 times the height of our first one is 2/3, plus 0.5 times the height of our second one, which is 1/2, plus 0.5 times the height of our third one, which is 2/5, plus 0.5 times the height of our last one, which is 1/3. All right, once again, let me crank this out on my calculator. 0.5 times 2/3 plus 0.5 times 1/2 plus 0.5 times 2/5 plus 0.5 times 1/3. And the answer I get is 0.95. All right, so that's my right rectangle approximation method. All right, so if I exit this for a moment, yeah, we'll keep those. And then I go back to the GeoGebra that's going on here. I already did a little bit of work here, and we can see that if I turn this on, this is our left rectangle approximation method, 1.2833. Looks familiar. Let's turn that off. Let's turn on our right rectangle approximation method, 0.95. That looks familiar. Excellent. And then if I turn that off and turn this guy on, I can see the exact area is 1.0986. And if I double click here, you can see the calculation. All right, it's not working. Oh, there you go. You can see that. All right, not working too much there, but there we go. What I calculated is the integral of 1 over x from 1 to 3. Okay, and so we can see that now that's the exact area, and we will learn how to do that in the future. But for the time being, we got to stick with the left. It's not going well. We got to stick with the left rectangle approximation method, the right rectangle approximation, and the midpoint approximation method, which I guess I should show you now, but running out of time, so I'll do it kind of quickly. So let me turn on the pointer again. Sorry, guys. I know you're getting bored. Let's get a different color. Orange sounds good. Let me erase the... Not letting me erase. All right, that stinks. All right, but let's do the midpoint approximation method. All right, so what we want to do is find the midpoint of each rectangle. Midpoint of each rectangle. The midpoint and the midpoint. All right, so what's unfortunate here, we still have each rectangle has a width of 0.5, but now we need to calculate all these new midpoints. Okay, so I'm not going to actually do it, but we want to figure out what f of 1.25, that's what's halfway in between 1 and 1.5, and then we need to calculate f of 1.75, because that's halfway in between 1.5 and 2. Then we need to calculate f of 2.25, and we need to calculate f of 2.75. Okay, and then we will do a similar calculation, MRAM. So all the widths are still going to be the same, but now we're going to have new heights. And it's not a big deal. Excuse me. We still need to calculate what that would be. Plus 5 times f of 2.25 plus 0.5 times f of 2.75. And we will get an answer, and the answer will probably be halfway in between these two, and the answer will probably be a better approximation. Remember, we're looking for, I think it was like 1.04 or something like that. But anyways, here's an example worked out all the way for you. Tomorrow in class, we will go over how to do this with a chart and how to do integrals on our calculator. And we will, I don't know, kind of keep moving on with some graphing stuff too. Please check out Miss Roshan's video. It's a pretty good one. It's on the homework calendar. Try to watch that sometime this week. And also, please be sure to read this section. All right, thanks, guys. Have a good one.